Good morning, good afternoon. Your first task today is a little do now quiz. Take the next 6 minutes to complete this quiz and then check back in. If you're subbing for me today, thank you. Pause this video, replay it when they're done. Now what we're going to be doing today is going to be comparing graphs, which we started 2 days ago. We talked about sine graphs and cosine graphs. We even talked about tangent graphs, which will not be included today. And so your first task is to really just annotate on your paper the difference between sine and cosine. And so for each one of these, we've got to identify which one is sine and which one is cosine and explain how we know. So let's look at some key features. They both basically do the same thing. They wave up and down, going in between -1 and 1. So we can see that they're bounded by the same, and they still use pi/2 to 2 pi. So they're using the same x's and y's. You may remember that the only thing that is different is that for one starts on the y-axis at 1, and one starts at the y-axis at 0, the origin. And remember that sine starts at the origin. And so we can just kind of put that one in here, that number 2 starts at origin, and therefore it's sine. And then for this other one over here, this is cosine, because that starts at a maximum of 1. What are the maximum and minimum values? These are going to be the same for both of these functions. And so the max value for each one of these, the highest point is going to be 1, which is a y value of 1. Or just 1. If we were to go on and do the minimum values, we would just look to the bottom parts of our graphs. And if we look for each one of these, they reach their lowest point at -1. So they both have minimum values at -1. And the real thing that we want to talk about that might be different today is this thing called horizontal distance. This is going to be turned into what we call period for the graph to make a full cycle. What do they mean by a full cycle? Let's trace it from the beginning on the y-axis for this cosine graph. I want to know when this graph gets back to its start and is going to repeat that cycle again. And that's going to take all the way until 2 pi. And we can see that's the full cosine graph. After that moment, it will repeat that cycle over and over again. And so how much to complete one cycle? Well, we would just call that 2 pi. What about for sine? Sine starts at 0, goes up, comes back to 0, but that's not a full cycle yet. It's got to go down and come back up. And in that way, it's also going to complete a cycle at 2 pi and then complete the same things. And so let's just annotate this. Well, we have annotated this. Let's put that down. The full cycle for either one of those is going to be 2 pi. The y-intercept we've already discussed. For cosine, it was 0, 1. And for sine, it was 0, 0. And that's true for the parent function, regular sine, regular cosine. And we could talk about the other 5 key points today. And so if you were to go back up and really annotate the 5 key points for each one, we know that as they go every 90 degrees for cosine, we go from max to mid to min to mid to max. But sine has a different order. It starts in the mid, then goes to max, then goes to mid, to min, and then back to mid. So we're going to have to remember those 5 key points today because we're going to be graphing these and then moving them about. So let's go down below and let's take some notes. So go to your notebooks. You already have this graph for sine labeled in your notes. And so what we need to do is we really just need to add a second section to our notes. And this will be 6.05. And we can call this is a crazy word, sinusoidal That's right. Transformations. And you already have this in your notebook. We have this in 6.03. No need to copy it down again. So what we really need to kind of stamp at the beginning is that we'll be talking about the standard form for any sinusoidal transformation. And so that standard form is y equals a sine of bx plus c plus d. Now, it should be noted that this is the parent function. This kind of tells us what's going on with those transformations. This always could be cosine as well. And so we can change between sine and cosine, even though we're calling them sinusoidal functions. Cosine is going to play by very similar rules. And so what we need to do is we really need to identify what all of these letters do. What do A, B, C, and D do to our sine graph that is pictured above? Each one of these letters is going to get its own definition. Midline is going to be, and I'm just going to kind of mark these down here. Midline is going to be this part right here, whatever is added or subtracted. And I'm going to include that definition below it, just really to annotate what this tells us. The midline is the middle of the graph. It's the middle of the function. That might seem obvious, but another thing that's really important about midline is that, I'm sorry, I'm staring at the word middle. Did I misspell that? The other thing that you need to know about midline is that it has an equal distance to the maximum and the minimum of whatever that graph is. So what we could do is we could come up to these graphs and we could draw a dashed line in here and label that as our midline. That's in the middle, and I can actually see to the top and to the bottom, it has an equal distance. That's how I know it's in the middle. It seems simple, but it's a very, very important distinction. The other thing that we're going to have to know today is this A value out front. It's going to be listed as a coefficient or written as a coefficient, and that's going to be the amplitude. And the amplitude of our graph is a vertical stretch. What does that mean? It means it's actually going to take this graph and grow it up or down. And so what this is going to be really the distance between the midline and the max or min. Well, how could we find the amplitude of this graph up above? Let's go annotate that. And if I find my midline right here, and I actually look at the distance from the midline up to the maximum, that's a distance of 1. So it must be that our A is equal to 1 here. Okay, it's the same there and there. And what I should say about our midline is that our midline here was 0. It was the line y equals 0, because that was where the middle of our graph was if I trace it all the way back to the beginning. So we see that midline is the middle, and we need to find our middle to really find our amplitude, the distance between those two. The other thing that we'll be talking about today is period. And period actually comes from the letter B in here. Now, we're not going to talk about C today, so we'll just leave that in our notebooks and annotate that one tomorrow. B represents period. And period is the amount of time it takes to complete one full cycle. And we need a formula for period. Our formula for period is P for period equals 2 pi divided by b. Whatever that b term is, we're going to take it and we're going to divide it by 2 pi. And that's going to tell us the period of our graph. What was the period here? The period here was 2 pi. So if I plugged in, really, and solved for b here, our b value would be 1, because 1 times 2 pi is going to be that 2 pi. Anyhow, these are the key words that you're going to need to know. Amplitude, distance from midline up. Midline, well, that is the middle. And period, how long it takes us to complete one full cycle. In this graph, it was 2 pi. So you can see how that's stretched out over the course of 2 pi and then would repeat. Let's go and do an example of actually graphing one of these start to finish. And here's our example. We have the function. I don't know if you can see it. This is going to go in your notes as well. Y equals 2 sine of x plus 3. And some very first things that I'm going to do is I'm going to annotate this about what I've been given and what that tells me. And the first thing that I notice is that this is a sine graph. All right, so I know that this is going to start at, instead of saying the origin, I'm going to start saying the middle. I didn't misspell middle. I was going crazy before, staring at the word for too long. And so sine tells us we start at the middle. Remember, cosine starts at the maximum. So sine starts in the middle. We might be tempted to come over here and put a point right in the middle, but don't do that. I'm going to erase mine because that middle is actually going to be shifted on this graph. So let's actually look how I know that. And that's because we have a new midline. And our midline this time is at y equals 3. Normally, it's right in the middle. The other thing that I know is that 2 is the amplitude. And this is that stretch. That's going to be that distance between the midline and the maximum and minimum values. And so let's actually see what we get here. And so when we graph this, our midline, I already said, is going to be at 3. So the first thing I'm going to do is I'm going to come and put a dotted line on whatever my graph is at y equals 3. That's going to mark the middle of my graph. From there, I'm going to use my amplitude, and I'm going to actually count up and down 2 units. And so this is going to be how much my graph goes up and goes down from the middle. So we can already see that our graph has been shifted and stretched. Instead of going up just 1, it's going up 2 from that middle. And so what else do I need to know? Well, I've got to get my scales down. So let's call this pi over 2. Let's call this pi. Let's call this 3 pi over 2. And let's call this 2 pi. Do I have to worry about period here? No, I don't. And here's why. Nothing has changed on the inside there. So our period is still 2 pi. Everything is good and gravy. So I'm going to complete one full cycle in 2 pi time. And so now let's think about our 5 key points. For sine, not only does it tell me to start in the middle, I know that I'm going from mid to max, back to mid, to the minimum, back to middle again. And so if I follow this order for sine, all I have to do is now put those 5 key points in that order. So we're going to start at the middle. That's at our midline right here. And then at pi over 2, we go to our maximum. So here's pi over 2. Our maximum is now at that green line. Then back to the middle. Then back to the minimum. Then back to the middle again at 2 pi. And you can see that the shape of our graph looks the same. It's just that it's been stretched up 2 units and it's been shifted up 3 units from the original parent function that's listed above. And so overall, this is what your graphs will look like. These are the annotations I want to make. And this is really the order and the rules I want to follow. Let's see if I have any other prompts down there. I don't. So take an extra 30 seconds and make sure that you have this all cleaned up and good and in your notebooks. Now what you will be doing is you'll be doing the exact same type of problem. You have a you do round 1 question. This should take you 5 minutes on your own. Once you get done with those 5 minutes, I'm going to reveal for you the answer. If you're watching this video, just press pause because I'm about to reveal the answer. Okay, some annotations from the you do round 1. I've got my amplitude, midline, maximum, minimum, and period all found. How did I do that? The amplitude just found from that A value out front. The midline found from that plus or minus D value at the end. Notice how I wrote it as an equation, y equals. You should too, because it is a line. Your maximum and minimum can be found by just taking your mid and adding the amplitude or subtracting the amplitude. Remember, that's the distance from the middle. And so if I add 3 to it, I get 2. If I subtract 3 to it, I get -4. And your period, again, has not been changed. We're going to leave that as 2 pi. Now we're going to put this all on our graph using those features that we've already identified. And so let me just scroll down very quickly, or rather slowly. Okay, so we've got 3 sine x minus 1. I'm going to just rewrite that here. We got to sketch the midline with a dotted line. We already identified that's going to be -1. I'm not only going to sketch it, I'm going to label it y equals -1, just to get good practice. Then we're going to sketch the max and min lines with a highlighter. Maybe you have a highlighter, maybe you don't. But our max and min, remember, we count from our amplitude up. 1, 2, 3. That's going to be our maximum. Remember, we got to go both directions from our middle. So I'm actually going to label that our max. And then I'm going to go down 1, 2, 3. So our amplitude tells us how far in both directions we've got to go. Good. And then we've got to draw our first cycle. And so we've got to remember that this is sine. So what's the order? Well, we've got to go mid, max, mid, min, back to mid, in that order. 1, 2, 3, 4, 5 key points. But before we do that, we've got to make sure that we got our axis labeled. And so we're almost always, especially if our period isn't changed, going to be counting by pi over 2, pi, 3 pi over 2, and 2 pi. Sorry, that's kind of hard to see. But that's just from those 90-degree angles on our unit circle. And so now that we've got our axis labeled, we can start in the middle, which is no longer at the origin. It's on that dotted line. And our maximum is the high dotted line, the middle back to the midline, the min back to the bottom, and the mid back to the midline. So we're not using our x-axis as our middle anymore. We're using different points. And now we can repeat these points throughout the graph by continuing. We can go back -pi over 2, and we can go backwards here. We can go back -pi. That's just going to repeat. You can kind of see how I'm going in the opposite order over here. -3 pi over 2. Same, that one's going to repeat and go up. And you can kind of see how the cycle continues. And I can continue that cycle in both directions by just really repeating what is happening and using my scale in the negative direction and further in the positive direction. There it is. Amplitude, midline, your 5 key points in the order listed. Now is your turn to try another. I said it was time to try another, but I'm also going to do this one with you. This one's also going to go in your notes. I know it's a lot of notes today, but we'll get a lot of practice in with these notes when I come back. And so this one we can see is a little bit different. We have cosine, so we've got a different order. We've still got an amplitude of 3. We've got a midline of y equals -3. All right, and we see its cosine, so we know it's going in a different order. I'm going to remind myself up above what cosine's order is. Cosine, remember, goes from max to mid to min to mid back to our max, and that's our full cycle. But the other thing that we have to remember is that now we're actually changing the period. So this is our B value. And in order to do this, we're also going to have to find what that period is and adjust our x-axis. So before I even do that, before I even consider that period, let's start with what we already know, which is our midline and our amplitude. Let's go put a dotted line down at our midline at -3. Now let's use our amplitude. I'll put this in green. Our amplitude is also going to be -3. So let's go up 3. That means our maximum is actually going to be at 0. But remember, we got to go down 3 as well. I say that because a lot of people will just go in one direction. Make sure your middle's in the middle, that you have a maximum and a minimum. And so we could start plotting our points again and put our scale down there, but our scale is going to change because of our period. And so let's remember our period formula. Period equals 2 pi over b. And in this case, our b value is pi over 2. So we have 2 pi over 2. And we just got done talking about what the heck we do when we have a fraction in a fraction. And we got to use keep, change, flip. So to do this, we're going to change this. So we're going to keep the 2 pi, call it 2 pi over 1, change it to multiplication, and we'll flip the bottom part to be 2 over pi. And when we do this, our pi's are going to cancel, and we'll just have 2 times 2, which is 4. And what this allows me to do is know that this is going to be one full cycle. Notice how we're not counting by pi anymore. We're not counting by 2 pi anymore. Our full cycle is going to be 4 whole units long. So I could just kind of count 1, 2, 3, 4 and know that that's going to be a full rotation. And so we know we need to get to 4. What I'm going to do is I'm going to skip some. So we'll call this 1, 2, 3, 4. There's my x-axis labeled as well. So I've got my y's and my x's all labeled. And so now I've got to think about my key points. Whenever we want to do this, I know that there's 5 key points, but we know our first one for cosine is going to start at the maximum. And so what we really got to do is just divide the other 4 up. So we're always going to take this and divide it by 4. Well, in this case, 4 divided by 4 equals 1. So what that tells me is that we're going to have a midline at 1. So our max is at 0, our mid's at 1, our min's at 2, 3, 4. And we want to make sure that we end wherever our full cycle is. So this one works out really, really nicely because now I can just go in order 1, 2, 3, 4. And so our max is at 0, our mid's at 1, our min's at 2, mid, and then max again. And so we can connect those all together. We can even go backwards if we'd like, get real crazy. And complete that cosine cycle going the other way. But this is really what I need to see. What I can see is I've got our midline, our max, and our min, that our graph goes back and forth in between. And I can see that we have a full cycle that ends at 4. And I did that with all of this math over here. Okay. So you've got to do some similar calculations when you are given a changed value for this b right here. So pay attention to that. Use this formula. Whenever you get that formula, you can cut it up into 4 pieces to allow you to know how you're going to do that graph. Good luck.